Welcome to section 17 of KMF 170 puzzle. Let us start with the first question. A committee of 4 people consisting of 2 men and 2 women is to be selected from 5 sets of fraternal twins, where each set consists of 1 man and 1 woman. If only one person from each set of twins may be selected for the committee, what is the total number of distinct committees that can be formed? So there are 5 sets of twins. So there are 5 men and 5 women. And we need to select 2 men and 2 women. Let's at first select 2 men from 5 sets. That is 5 combination of 2 equal to 10. So 3 sets remain. Let us select 2 women from the remaining sets. So 3 combination 2 equal to 3. So the total number of distinct committees will be 10 multiplied by 3 equal to 30. So the answer will be option D. Let's move to second question. 5 gift cards will be distributed among 10 people so that no person receives more than 1 gift card. The gift cards consist of one $100 gift card, one $50 gift card, one $25 gift card, and 2 $10 gift cards. How many different distributions of the 5 gift cards among the 10 people are possible if the 2 $10 gift cards are considered to be identical? So there are 10 people and we have 5 gift cards. Let us distribute the 5 gift cards among 5 people. Among 10 people. So at first we can distribute to 5 people. So 10 C5 equal to 252. Now see the condition. 2 gift cards are identical. So among the 5, 2 are identical. So how can we find it? There are 2 ways. Let us see the first one. We can distribute the identical 2 among those 5 people. 5C2 equal to 10. So we get 5 plus 2 equal to 7 people and 3 peoples are remaining. So we'll distribute 1 card to each of the 3 people. So 3C1 equal to 6. So the total how many different distributions? So the total distributions will be 252 multiplied by 10 multiplied by 6 equal to 15,120. There is an alternative way. The first stage is the same, 10 C5 equal to 252. And in the second stage, as the 2 cards are identical, we can do it in this way. 5 factorial divided by 2 factorial equal to 60. So we can multiply 252 by 60 directly. We will get the same answer, that is 15,120. In the third question, we are given zeros and ones in various rows and columns. So the table above consists of 10 rows and 10 columns. Each entry in the table is either a 0 or a 1. A 0 is to be selected at random from the table. What is the probability that the 0 selected will be in a row with an odd number of zeros and in a column with an odd number of zeros? Give your answer as a fraction. So the condition is the 0 which will be selected must be from odd number of row and odd number of column. I have just identified the odd number of rows and columns. However, the condition is the 0 selected will be in a row with an odd number of zeros. So in a row, the number of zeros must be odd, and in the column, the number of zeros must be odd. So there are 10 such zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is the total number of zeros? If you just count all of the zeros, you will get that there are 55 zeros. So selected zeros are 10 and total zeros are 55, so the probability is 10 by 55 equal to 2 by 11 in its reduced form. So the answer is 2 by 11. We are in the fourth question. The vehicles of a company W are numbered consecutively from 1 to 650. The vehicles with the number that ends with one of the digits 1, 2, 3, 4 or 5 are used by Division 1. Vehicles with the number between 130 and 389 inclusive are trucks. What percent of the company vehicles are trucks used by Division 1? So we need to find out the number of trucks and the number of trucks used in Division 1 and then take the ratio. So total number of vehicles are 650 and total number of trucks are 389 minus 130 plus 1, as these are inclusive numbers, so we have added 1. So the total number of trucks are 260. Notice that in the Division 1, vehicles with a number that ends with one of the digits 1 to 5, and in case of trucks, the digits are 0 to 9. So 1 to 5 are just 50% of 0 to 9, that is 10. So 50% trucks used in Division 1. So total trucks are 260 and 50% of 260 is 130. So the percent of the company vehicles that are trucks used by Division 1 can be found out by taking ratio between 130 and total number of vehicles, that is 650, and multiply it by 100 to take out the percentage. So we get the answer, that is 20%. So in this question we can see a cube, and the question says if 20 red cubes and 7 white cubes, all of equal size, are fitted together to form one large cube, one shown above, what is the greatest fraction of the surface area of the large cube that could be red? So we need to find out the greatest fraction. So we need to put the white cubes in such a way that it takes the smallest portion of the large cube. So let us put the white cubes in the middle of each side. So in the front side we can see that there are 9 cubes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 6 sides, so total surface will be 9 into 6 equal to 54. As we have put a white cube in the middle, so there will be 6 cubes in the large cube, each one in each side. So to find out the surface area of the red cube, we can take the difference of 54 and 6. So 54 minus 6 equal to 48. So the greatest fraction of the surface area of the large cube that could be red is equal to 48 divided by 54. And in the reduced form, we'll get 8 by 9. We are in the sixth question. If one number is chosen at random from the first 1000 positive integers, what is the probability that the number chosen has at least one digit with the number 6? Give your answer as a fraction. So the question asks for a condition, that is, the number chosen has at least one digit with the number 6. So the total number is 1000, sorry, integers, and at least 6, the probability of having at least 6 can be equal to 1 minus probability of having no 6. So probability of having no 6 is 271. How have we found it? Using the counting method. That is 9 uh, in the third place. That is the place of 100. And in the tens we get also 9. And in the unit digit we get also 9. So 0 to 9 is equal to 10. We have just crossed out 6 and we get 9. So multiply 9 into 9 into 9, we get 271. And now the probability of having at least one digit with the number 6 is 271 divided by 1000. In the seventh question, 3 coins, 2 10-cent coins and 1 5-cent coin are to be flipped simultaneously. For each of the 3 coins, the probability that the coin will land heads up is half. What is the probability that the total value of the coins that will land heads up is 15 cents? Give your answer as a decimal. So the condition is total value of the coins must be 15. We can do it in many ways. There is another condition. The coins are flipped simultaneously. Let's see the design. We can have a 5-cent coin and then 10-cent coins, or we can arrange it as a 10 10 5 or 10 5 10. Whatever way you think about, the result will be the same. So to have the total value is 15, we get 10 plus 5. So there must be 2 heads. So the probability of per head length will be half. So half multiplied by half equal to 1 by 4, and as the question asks our answer in decimal, we get 0.25. We are in question 8. On a 60 question triples test, Mercy answered correctly all questions she understood, and she guessed randomly on all questions she did not understand. She answered 52 questions correctly on the test. How many questions did Mercy most likely understand? The question is a little bit tricky and a little bit complex, but let us break it down. She answered 52 questions correctly on the test. And in the first sentence, it says she answered correctly all questions she understood. From the second sentence, we do not know whether Mercy understood 52 questions correctly or not. We just know that she answered those correctly. Here's the twist. So we can do it in 3 ways. I'll show you the 2 ways here. So total question is 60 and she answered correctly 52. So she didn't answer correctly is 8 questions. So from the 8 questions, some of them could be wrong and some of them could be right. We do not need to. Let us guess and break it into half. So 8 guessed wrong and answered wrong. And she guessed 8 questions wrong but answered correctly. So 8 plus 8 equal to 16. So 52 minus 16 equal to 42 questions she is most likely to understand. If you do not get it yet, let us try another method. Suppose that x is the number of questions she understood rightly. So x plus 60 minus x divided by 2. As we do not know how many questions she understood rightly and answered rightly or wrongly, we have divided it into 2. So 60 minus x divided by 2 equal to 55. Sorry, it will be 52. So it will be 50. We're in the ninth question. A telephone system has n telephone lines. For each of the n lines, the event that the line will fail during the certain reliability test has probability 0.3, and these n events are independent. If the probability that at least one of the n lines will not fail during the reliability test is greater than 0.99, the question is, what is the minimum value of n? N is the number of telephone lines. Let us write it down. Probability of failure is 0.3, so the probability of success will be 1 minus 0.3 equal to 0.7. Notice that in the question we have given that probability of at least one of the n lines will not fail is greater than 0.99. So at least one of the n lines will not fail can be rewritten as 1 minus probability of all lines will fail. So if all line fails and we take the difference from 1, we'll get the probability of at least one of the n lines that will not fail. So given that probability is greater than 0.99 and we have used our rewritten equation, that is 1 minus probability of all lines will fail less than 0.99. In this case we have alternate the sign. So after solving we get that 0.3 to the power n, where we get that 0.3, that is the probability of failure of all lines. So that is a condition. 0.3 to the power n should be less than 0.01. So we need to find out the value of n. Let us do it. When n equal to 1, we get 0.3. So when n equal to 2, so 0.3 into 0.3 equal to 0.09. In this way, when n equal to 4, we get 0.0081, which is less than 0.01. But up to n equal to 3, we get 0.027, which is greater than 0.01. So our desired number of lines will be 4. So the answer will be n equal to 4. We are in the last question of section 17. The probability that event R will occur is 0.65. The probability that event T will occur is 0.47. Quantity asked for the probability that neither R nor T will occur. Notice that we do not know whether these events are independent or mutually exclusive or whatever. So what we can do is to calculate using different conditions. So the probability that neither R nor T will occur. At first, we will find the probability of R or T. So the formula will be probability of R plus probability of T minus probability of R and T. So if you use the formula of independence, then in case of probability of R and T, you will get probability of R into probability of T. And if you use the formula of mutually exclusive event, you will get probability of R and T equal to 0. You can choose whatever you want to do. So in this case, I have got, using the formula of independence, 0.8145. Now the question asks the probability that neither R nor T will occur. So 1 minus probability of R or T will occur. That is 1 minus 0.8145 equal to 0.19. So if you take that events are mutually exclusive, then you will get the answer as 0.12. So in both cases, quantity B, that is 0.47, is greater. So whatever condition you choose, the answer will be option B. All for today. Thank you.